Hello, this is the second part of the help for assignment number 3. We are going to do now problems 7 to 12. And most of these problems deal with projectile motion. And in projectile motion, you have, as was done in detail in lecture, you have an horizontal motion and you have a vertical motion, and they are both independent. The horizontal motion is described by two equations only. That it says that the displacement is the initial x component of the velocity of the projectile times the time that it has passed. And whether this is the total time of the flight, that will depend on which position you are calculating. And also the velocity at every time is just the initial velocity, there is no acceleration. Whereas in the vertical motion, you have the usual equation for motion in a line, and the acceleration is the acceleration of g, and the component of the acceleration is negative, because in projectile motion you have chosen this as your reference frame, where the vertical direction points up and is positive. The component of the vertical velocity at any time is given by this equation. And you also have the equation that doesn't contain time, which is this equation over here. So going to the problem number 7 is a problem of a baseball that is thrown horizontally from a given height. And we did this problem in lecture, so it's thrown horizontally with a certain speed. So the initial speed is just in the horizontal component, and it has a height h. And what you wanna calculate is where is the ball after a certain time. Well, in the horizontal position, you use equation number 1. So you use 1 to compute where in the horizontal direction it is, and you have to use 2 to compute where it is in the vertical direction. And you have to remember that the initial velocity in the vertical direction is 0. Problem number 8. Problem number 8, we have to adjust the size of the canvas here, just 1 second. Problem number 8 is a projectile that is thrown from a given height from the ground. So you are given a height here, for example, in my case is 1 meter, but you will have different numbers. But now it's not thrown horizontally, but it's thrown at an angle. And what is given to you is this angle and this velocity. So from this, you calculate now that the x component, the horizontal component of the initial velocity, is that if the angle is given with respect to the horizontal, which is the case, and the vertical component, it will be this one. So you calculate these numbers, and then you can go to find, for example, the maximum height. What is the maximum height? Well, the maximum height of a projectile is defined when the vertical component of the velocity vanishes. So if the vertical component of the velocity vanishes, you go here, make this equal to 0, and you find the time for maximum height. And once you find the time for maximum height, you can find the height, or you could come directly here, because this equation tells you the following: if the vertical component of the velocity is 0, it means that the maximum height will be given by v0y squared over 2g. And you already know what v0y is, so you are done in that problem. The speed of the ball at the maximum height is that, because at the maximum height, again, the vertical component of the velocity is 0, because at maximum height, always the projectile is just moving horizontally, which is the same component that it has when it was launched. Problem number 9. This is the problem of dropping a bomb, and it's typically on video games. So you have a plane. Let's just try to see if we can draw an airplane here. Close. It's traveling horizontally with a certain velocity, horizontally. So this is the velocity. And it's at a certain height from the ground. So this is the problem. And now drops a bomb. So when you drop something from here, these, just after dropping, it has the velocity of the plane. So it's a projectile now that is launched horizontally. So you go back to problem number 7. Because the distance that this is going to travel horizontally is equation 1. That distance is, that's v0x, which is v0x, which is given. That distance is that. So you say, well, what was the time? Well, the time is the time to come down a height h. And that time, we know that it can be calculated from here. The direction that the bomb is moving is given by this angle. This angle, the tangent of that angle, is the vertical component of the velocity here divided by the horizontal, which is v0x. So you say, well, what's the vertical? Well, the vertical is easy, because you come back here and you say that the vertical component of the velocity is the initial vertical component of the velocity, which is 0, minus g times this time, because that's the time to get down here.